And then Tammy can start the meeting, and I'll keep letting folks in.
Love you.
Love you, Cole.
Thanks. Yeah.
We are this close.
We're this close.
We are this close. Of wanting to making history.
This close to changing the world.
We are this close.
This close to making sure no child suffers a crippling disease
Ever again. This close.
We are this close to ending polio.
Ending polio.
All we need is you.
This close.
If we donate now, we may lose this chance forever. Help Rotary make history at endpolionow.org.
Like it.
That's awesome. Awesome.
I figured out how to do it.
Yay. Well, thank you for sharing that. As I said before, and probably a lot of you too, just that effort globally for one group of people to be able to make that difference just means it's so important for us to be Rotarians and to continue the fight. So thanks for sharing that with us. I'm ready. Are you ready, Christy? Are you recording?
I am.
Okay. Welcome to the Rotary Club of Kerrville, everyone. It's so good to see each of you. We have almost a third of our entire club attending today, and that's just so exciting. I know it's hard to be away from each other and to stay engaged, but between Christy and Clint Morris, everyone's doing such a good job, and our club is just still active. I'd like to ask you to turn off your cell phones, but before you do, please check in on Facebook and let everybody know that you're participating in your Rotary Club meeting. I believe that Mike Wilson is going to say our invocation today. Oh, you're muted.
Can you hear me?
Yes.
Good. Let us pray. Dear Lord, we're grateful for our many gifts and blessings. And in this time of pandemic, we pray that you will comfort, care for, and be with all those in special need of you this day. Beyond the virus, Lord, we're concerned there's evidence of another growing sickness in other parts of this country, an erosion of civility in the words and actions of a number of our citizens. And we pray that you will help our nation find a rebirth of values in how you would have us treat each other, that all may act with civility and kindness and with respect for our laws and for each other. Finally, Lord, bless Rotary that we may serve others, and in doing so, serve you. In Christ's name, amen.
Amen. And if you will join me in the pledge. I pledge allegiance to the flag
of the United States of
America,
and to the
Republic, which
stands
one
nation
under God,
God,
indivisible,
with
with
liberty and justice for all.
Thank you. Hey, Clint, would you like to introduce our speaker? I'm so excited for this particular program.
Well, so am I. Thank you, President Tammy. Can you hear me?
Sure can.
Good. Well, I've really looked forward to this program because I am a trained weather spotter for the National Weather Service and keep all kinds of weather data at home. And our speaker today, when you read his bio, set up in Austin, and he went to the University of Texas. And I said, well, wait a minute. The leading meteorology school in the nation is at the University of Oklahoma. And sure enough, I read the second line, and it said, and then he transferred to the University of Oklahoma, where he got a Bachelor of Science degree in meteorology. He has since, after graduation, worked in various locations for the National Weather Service and is currently assigned to the Austin office. And his primary job is to be the liaison between the National Weather Service and local media, citizens, county, state, and federal agencies, as well to conduct storm damage surveys and community outreach. And so please welcome our speaker, Paul Ura, who is the warning coordination meteorologist at the National Weather Service, Austin, San Antonio, who will talk to us about the storms we had this past spring and other things that he thinks would be of interest to our group. So let's give a warm Rotary virtual welcome to Paul Ura.
Yay.
I appreciate it. Thank you. So yeah, as the slides kind of pop up here, just quick little story. So so the University of Texas at Austin used to have a meteorology program back in the 70s and early 80s, and unfortunately the program went away. So I'm a diehard Longhorn, grew up in Austin, and have grown to hate both Aggies and Sooners. And so my issue was that I couldn't get my degree from UT Austin, so I had to go to an arch nemesis and an enemy territory. So I chose the enemy territory of Oklahoma by chance. And so even though I technically have my degree from Oklahoma, I am still a diehard Longhorn fan. So I'm emotionally torn inside whenever football season happens or anything. So especially lately, since OU has done a lot better than Texas has. But anyway, I digress. So for the people that are keeping track, how long do you want me to talk until? Give me a time.
Well, until about, you got about 30 minutes, but
Okay.
Save some time for questions out of that 30 minutes.
Okay, sounds very good. So that so the first slide there, so kind of interesting. So I kind of called this this whole talk, protecting South Central Texas. Even though I'm the Austin San Antonio office, we have 33 counties of jurisdiction, which I'll show you here in a second. But primarily, if you've lived out there in Kerrville long enough in the hill country, you kind of know how dangerous the flash flooding is. That's kind of one of our main weather dangers here. Our most important, I would say, weather danger in South Central Texas is the flash flooding. And so that picture there of the bus, that was here in this town of New Braunfels, where I currently live. And to show the image of a bus wrapped around a tree, that just kind of shows you the power of water. And as Clint said, as warning coordination meteorologist, one of my duties is to actually go out and do damage surveys. So that was a damage survey from a flood we had back in on June 9th, 2010. And then closer to home, if you will, I was out there in Kerrville a day or two after, in late May, when you guys had all that hail and the wind, kind of doing what I would consider a damage survey, trying to figure out, was it a tornado or was it something else? And I'll kind of get into that in a little bit when I go on. So next slide, please. All right, very good. So this slide actually kind of shows what the National Weather Service looks like on a whole for the continental United States. So there's 122 field offices of the National Weather Service. So what the map shows is that every county in the United States has a jurisdictional weather service office, including actually the island of Guam, out in Hawaii, and actually in Puerto Rico, and then 3 offices that actually handle the huge landmass of Alaska. All these offices are manned 24/7. We have continued to be manned 24/7, even during this whole COVID pandemic. Persons like myself, I'm a manager / supervisor of the office, so we were told to basically start teleworking since we don't work the rotating shift work anymore. But on occasion, I still do. So as an example, on the 4th of July weekend, I had to work 4 graveyard shifts. So I had to kind of get back in the routine of pulling an all-nighter and then sleeping during the day and then having one meal. I call it my graveyard shift diet, because I typically lose about 5 pounds because I only eat once a day because my body is just so whacked whenever that happens. But each office is pretty small. We have about 20 to 25 people in each office that handles the 24-hour operations. And that's not a lot of people when you consider that about 2/3 of the time, there's only about 2 people in the office. Most times people are in the office are during the daytime with the administrators and such. Next slide, please. This is going to be a slide kind of showing our close-up view of our jurisdiction in my area here. And so what it is going to be is, 33 counties of South Central Texas. It encompasses most, if not all, of the hill country. and portions all the way to the Rio Grande River, and then all the way, if you know areas east, into the coastal plains of Texas, basically east of Interstate 35. So pretty drastic different weather across our 33 counties. Population-wise, you're kind of talking about upwards between 5 and 6 million people, and growing, definitely. Typically what we have is on a day-to-day basis, we get our funding from Department of Commerce. It goes down to NOAA, and then it gets funneled down to the National Weather Service. And you can see the image there of our small little office. We're right by the New Braunfels Airport. So if you're a pilot and fly to New Braunfels, you actually are flying really, really close to our weather office right there. So our job is to protect the people and the lives of everybody that lives in these 33 counties. It's as simple as that. And usually we do that by putting out accurate forecasts, or what we would consider accurate forecasts. Maybe you wouldn't, but we try our best. It's not from a lack of trying, trust me. And then also putting out the watches and the weather warnings. Next slide. The next slide is actually going to be kind of an overarching showing of how active Texas is when it comes to weather. This is a map that actually shows the number of billion-dollar weather events that we've had since 1980. And if you can tell by the colors on the image, we are pretty red here in Texas when it comes to the number of billion-dollar weather events. So what is a billion-dollar weather event? It's basically which weather event causes $1 billion worth of damage. That can be the serious droughts of Texas, the hurricanes, ice storms, for us, the really big flooding events like happened during Harvey. And believe it or not, even some tornado events can be billion-dollar events, and even hail events. And those big hailstorms that we had at the end of May have actually accumulated to another billion-dollar hail event in the state of Texas. So we're very, very active in Texas. That's what it kind of comes down to. Next slide, please. So this next slide will kind of show you what we're going to be talking about real quick. And you can go ahead and even get to the next slide already, because we're going to be talking about all the different sort of thunderstorm hazards, including lightning, flash flooding, tornadoes, microburst winds, and tornadoes. And we're starting off talking about lightning. And, you know, lightning is, you know, it's, people don't really think about it much as a killer. Maybe you did a long time ago when we had so many people dying on a golf course and everything else. But to be honest, we've done a really good job of kind of knocking down the amount of lightning deaths in the United States. We are down to, last year we only had 20 deaths in the United States from lightning. Compare that to maybe 30 or 40 years ago when we averaged 50 to 60 people dying because of lightning. The main issue is, of course, the heat and the power. So 50,000 degrees temperature, then you have on roughly average about 300,000 amps, which is a whole lot more than your typical wall socket. So, you know, you get hit with that amount of heat and power, you're going to get typically seriously injured, and or unfortunately you could die. The big danger that we get from lightning is that most people that are struck and especially killed by lightning, it's actually not raining where that lightning bolt hits. And those are, the one image there on the bottom right is a good example of that. It's called a bolt out of the blue, where the lightning can actually strike up to 10 miles away from a parent storm. So even if you're just hearing thunder, you're actually close enough to get one of those bolts out of the blue. So just be aware of that. Next slide. When we actually start looking at people that have actually been killed, and so this is data from about 418 deaths from lightning since 2006. And unfortunately, us guys, we are not doing so well. We are dying at a much higher clip from lightning than the females. And so guys, we need to do a much better job of listening to the women. And when they tell us to come indoors because the storm is coming or they hear thunder, then you better follow some direction. Otherwise, you're going to wind up on this pie chart, which is not a good place to be. Next slide. Most of the deaths that we actually get are from being outdoors. Obviously, a long time ago, we used to have some indoor lightning fatalities when everybody had corded phones and all that, but that's pretty much gone away. All the deaths nowadays are all outdoors, including a lot of people that tend to stand underneath trees for sheltering. The image of the tree there on the right, and you can see the bark being blown off the trunk. That was from a PGA golf event. I think it was last year, the year before. No fatalities, but you can see the people on the ground tending to some injuries. as about 6 or 7 people, I think, actually got impacted by the lightning. So it's the one place you don't want to be, is standing underneath or near a tree during thunder or during lightning. It's a tall object. It tends to get struck a lot. And I have the question there on the screen, is your car or truck a shelter? And the answer is technically yes. If you roll up the windows, you can have a good shelter by being inside that car or truck. Even though it's a metal object, the metal at that point acts as a Faraday cage and will actually direct the electricity around you. So don't be in an open spot. Don't be underneath a tree. And if you have to be, try to be in a building, a shelter of some sort that has walls, windows that can keep the electricity out. And your car or truck can actually fit that bill if you don't have a building that you can actually go into. So stay away from the trees. Next slide. So this is where we start talking about flash flooding. And, we call our area here Flash Flood Alley. You will not find a more prolific area in the United States where you have this perfect combination of urbanization, topography, and really massive rain events. And so we're called Flash Flood Alley in the country for a reason. We have more flash flood deaths that I know of than anywhere. We've had, in the next map, we'll kind of show that, but there's some flash flooding events in Colorado from time to time, and even in places even like Maryland, which is very hilly in some regions. But a lot of the other places in the country, they have flooding. They don't have flash flooding. Flash flooding happens quickly. That's why I call it flash, and it also moves very quickly. And it's the power of the moving water that really does the damage and really brings our fatalities into play in this part of Texas. The next slide will actually show a breakdown of our flood fatalities that we've had and flash flood fatalities that we've seen in my jurisdiction over the last 24 years. And believe it or not, we've had 156 people killed in the last 24 years because of flash flooding in this part of Texas. And by far, believe it or not, so there's a little factoid, there's 254 counties in Texas. My jurisdiction has 33 of them. And yet I own more than half of the deaths in Texas. So just think about that for a second. So this is the key location in Texas where we've got to be cautious. And you can see the raw numbers on the map. Those are the actual fatalities that we've actually had. So Kerr County is not doing bad. We've had 3 fatalities in the last 24 years compared to places like Travis County, Hayes County, and even Bexar County. Bexar County is second to only behind Harris County and Houston. And Harris County took the lead because of Harvey. Up until Harvey happened, Bexar County was the #1 county in Texas for flood fatalities in the last 20, 23 years or so. There's some places on the map that have zeros, if you notice. And it's not because they don't get rain, and it's not because they don't get flooding. It's just because they're flat. And when you have flat land, the water moves slow. And when you have slow moving water, it doesn't really sweep a car off the road. It doesn't sweep a car or a house off their foundation. So you're much more likely to survive a flood event down where it's flat. In the hill country, not so much. Next slide. Start getting into some of our, you've heard that saying, turn around, don't drown. And so this is kind of where we start to now talk about the weather safety with flooding. Those low water crossings around. One of the more recent deaths that we had actually in Kerr County, and I actually drove out there right past this event, was back in April of 2010. That was a gentleman that actually lost his life by going home after a school board meeting, if I'm not mistaken. His name was John Spikes, and he was killed off of FM 1340. Very windy road with a lot of low water crossings, and so kind of tragic. Long-term resident, it's not, the people that are dying from flash flooding are not visitors. I will tell you that again. They are not visitors. They are long-term residents of the area. And it's because they become complacent of the flood and driving through the low water crossings when it's somewhat flooded. And it just takes a moment for your car or truck to get released, because it only takes about 12 inches of water to sweep a car off the road, and a little bit more water, 18 to 24 inches, to sweep a large SUV or van or truck. So the faster the water is moving, the quicker your car or truck will get swept off. And then once your car leaves the road, your chances of survival are nearly nil, to be honest. And of course, that area up there by Kerrville knows very much about the tragedy in '87. That was the Comfort bus tragedy, Sunday morning. Campers trying to flee from the flooding rains that were happening. And unfortunately, I believe it was about 10 teenagers died. A lot of rescues via helicopter and everything else. So we're not immune to this, especially out in the hill country. So caution basically has to be used. Next slide. Let's start talking about hail for a second. Hail is pretty unique in that it has to be certain thunderstorms that produce hail. And to be honest, anytime that you start getting lightning in a thunderstorm is where you start to have ice in the thunderstorm. And that's why typically hail comes from thunderstorms, because you actually need that ice up there to create the lightning. When the hail actually starts to fall, when it gets big enough to fall, the really big hailstones, those baseball and softball sized hailstones, can actually fall at 100 miles an hour. So believe it or not, we've actually had deaths from hail before, human deaths. There is a lot of livestock deaths, if you call that, from hail. Chickens, cattle, etc. A lot of them die from hail. But obviously humans are pretty rare, but a lot of injuries. If you can imagine a big outdoor event like you have out there in Kerrville or something, or in the hill country, and a hailstorm pops up with golf ball to baseball size hail and no cover for folks, you can understand how deadly, especially how dangerous that could actually be. For all you aircraft enthusiasts, the bottom picture there is an aircraft. It was actually in Turkey that got too close to a hailstorm. But not too long ago, a couple of years ago, there was a flight that left San Antonio that was going to LA, I believe, and had to make an emergency landing in El Paso because they had encountered a whole bunch of hail. They got too close to a storm, got in a hail encounter, and basically busted out. It basically looked just like that plane there. So, you don't want to be hitting hailstones at 400 miles an hour. It's bad enough when you hit them when you're driving. And the best thing actually is to not drive through the hail. If you actually drive through the hail, you're actually going to make the dents bigger. So obviously you should never kind of get into the position when you're in a hailstorm, but it happens sometimes, and just try to seek some shelter for you and your car at that same time. Next slide, please. We're going to then kind of transition and talk about the strong winds that happen with thunderstorms. Kind of have a unique term for that. We call them microbursts and downbursts. Same thing. Most people, when we actually have a thunderstorm that produces a lot of wind damage, they instinctively just assume that there must have been a tornado that happened. And that's kind of wrong to think about. Most of our wind damage actually comes from these things called microbursts. They can be very small scale, mile or so, and we'll talk about the one that happened there in May. But what happens is that we basically have descending air. And so when you see pictures of like a rain shaft or something coming out of a thunderstorm, many times that rain shaft is bringing down colder air, a lot of wind, and when it hits the ground, it spreads out. Next slide. I'll show you kind of how dangerous it is to aviation, because when you actually have a downburst occurring, especially near an airport, and you have a plane taking off or landing, having certain wind directions and wind speeds are vital. That's how a pilot is able to adjust their flaps, adjust their engine speed, and everything is to already have a predefined notion of how they're going to land. And so when things change suddenly, that can lead to some aircraft disasters. The next slide will actually show one of the disasters that's very famous for being a aircraft accident because of a microburst, and it was the Delta plane crash, Delta Flight 191 back in 1985. I remember this as a child. I remember watching the news and hearing about this weather incident. And you're like, gosh, how can a big plane crash because of a thunderstorm? And it's, back in the day, we didn't have as robust radar. We didn't have as much robust radar in the actual planes themselves. They weren't trained as much as they are now. So it's pretty rare you get into any sort of large aircraft accidents nowadays because of microbursts. There's just a lot more delays. You know that by being in an airport, how many delays there are when it comes to lightning and thunderstorms in the area. So everybody is much more cautious nowadays. But, this was one of those key events that basically put microbursts on the map. And because of it, we're a whole lot more safer now. So just like anything, it took a tragedy and an accident to basically change training, especially of the pilots, to get more Doppler radars, especially at some of the airports, so we can see some of these very small sort of features. And that kind of leads us into the next slide, which is actually a screen capture of the radar from May 27th out there in Kerrville. And so if you remember that day, this was an event that happened, I want to say it was kind of around the 8 o'clock sort of time frame, late afternoon, early evening hours. It was kind of dusk and it was kind of getting dark. But this massive thunderstorm, severe thunderstorm, which we've been dealing with all afternoon, came in from the north and northwest and came right through Kerrville. The yellow boxes that we actually have on the radar there are actually severe thunderstorm warnings. And then literally a couple of minutes later, we actually wound up issuing a tornado warning because we actually saw some circulation in the thunderstorm there. And of course, that's the most important part about the Doppler radar, is that now we can see wind speeds at certain levels. Now, the one issue that we do have is that is the farther away you get from the radar is not able to see lower in the thunderstorm. And so, you know, out there by Kerrville, I'm taking a guess, we probably can't see, you know, the lowest 3,000 feet underneath that storm. And so a lot of the small tornadoes we wind up missing just because the storm is too far away. But in this case, I did drive out, and those pictures on the right are actually from my damage survey. I drove out the next day because obviously we had a lot of wind damage, especially on that road just above where the hospital is. And I thought I was going to write it down, and I forgot what it was called. But up there on the hill, there was a lot of widespread wind damage. Wind came up that side of the hill and took off some back porches on several homes. Pretty substantial wind damage to some homes up there, and many, many trees downed, damaged, torn apart, with hundreds of them in about a 2 or 3 mile swath leading from there all the way kind of southeast of town. And so driving back and forth through there, I didn't find any sort of narrow path. It was widespread. And so that led me to the conclusion that we didn't have a tornado out there. We actually had what we consider a microburst, a very widespread wind event. And the hail was impressive. Believe it or not, when I was out there the next afternoon, and I was talking to the gentleman whose house you see in the picture, he still had a pile of hail on the side of the house. It was 95 degrees outside, and there was still hail on the ground. That's how much hail fell. And many of you may have stories of how much hail was in your yard. It probably looked like it snowed, just like that one image there on the screen. It was a lot of hail, believe me. Next slide, please. And that kind of leads us to our last kind of hazard I'm going to talk about, which is the tornadoes. And you may have kind of grown up thinking that Tornado Alley was North Texas through Oklahoma, Kansas, Nebraska, and the Dakotas. And that's how, honestly, most of the maps are still drawn. If you Google Tornado Alley on Google and you hit the images button, you'll get all these maps that show the center part of the United States only. And that's wrong. This is a map that shows the verified tornadoes that have hit ground since 1950. And you can see that it is not just Oklahoma, Kansas, Nebraska, South, and North Dakota. It is literally the eastern 2/3 of the United States. They get some tornadoes out in the west over the Rocky Mountains, but the ingredients aren't very good, so they're very uncommon. But once you get past the Front Range of like Denver and Cheyenne, then you get a lot of, where there's humidity and there's thunderstorms, you can get tornadoes. And so that's why it's technically really, really widespread. Next slide. So this will kind of show how we rate tornadoes. One of the jobs that I have is that when I go out there to find a tornado, I have to basically put a number to it. And we call that the enhanced Fujita scale. 0s and 1s, 2s and 3s, and 4 and 5s. As you can imagine, the 4 and 5s are the most violent tornadoes. Those are crazy. Those wipe out towns. Those kill a lot of people, and they have winds over 200 miles an hour. The ones in the middle there, the strong tornadoes, are more rare than the common ones, but we tend to have some losses of life. Tends to a lot be with mobile homes and weakly built structures. The most common tornado by far is on the far left, and those are what we call the EF0 and EF1 tornadoes. They're on the ground for maybe a minute or two at best. They're hard to find. They're hard to see on radar. And a lot of times we won't know it unless we get a picture of it, or we come across some wind damage, and sure enough, there may be a skinny little path. So it's pretty rare to get the really strong ones. Much more common, and they happen honestly all the time. We don't hear about, I bet, the majority of them because they happen in the middle of nowhere. But it is something that I basically go ahead and will try to rank if I can find enough information. Next slide. So when we talk about the type of equipment that we use, here's some images of all the different stuff that we use to gather weather information. Our radar, those automated weather observing systems, we call them AWOSs, that are at the observation sites at the airports. So like Kerrville as an example, at the airport, they have an automated weather station there that takes minute by minute observations. We launch weather balloons, we have satellites, crazy expensive satellites nowadays that give you so much information. But the weather balloons and the airplanes do a really good job of measuring our upper atmosphere. And that'll take us to our next slide, which kind of shows you, oh, this is kind of nerdy science stuff, but these are called SKUTs. These are plots of the atmosphere when it comes to what we need to know as meteorologists. We need to know the temperature, the pressure, and the humidity and winds at different levels of the atmosphere. And that helps us forecast what's coming. So if it's a dry atmosphere, we can assume that, you know, we're probably not going to get much rain. If it is a very, very wet atmosphere, we can get a pretty good idea that the chances of rain will be increasing. So for weather balloon sites, there's about 125 of them in North America. Not very many when you consider the size of North America. On the globe, there's, gosh, I think there's probably close to 1,000 of them. They launch weather balloons everywhere, especially over land masses: Antarctica, Africa, Australia, Europe, Asia, Russia, everywhere. The problem is all the gaps. Think about all the oceans. What ocean covers about, what, 60, 70% of the Earth's surface? We don't launch a lot of weather balloons over the ocean because we don't have a whole bunch of places to launch, except maybe some islands here and there. So a lot of the Earth's atmosphere is unmeasured, and that's not good. So the one technology that has really taken off is utilizing aircraft. As they're flying cross-continent, over the oceans, wherever, they can take weather measurements for us. And the next slide will kind of show you the impact that the COVID has actually had. On this top map will actually show all the different areas and places where aircraft were taking observations going across the globe. And you can see those as the blue trace marks in January, that top picture. So, you know, the flights from Europe to South America, from the West Coast all the way to Australia, all of those are taking observations. And in fact, airplanes typically give us about 800,000 weather observations per day. Now, what that means is that when the aircraft were shut down because of COVID, yeah, we basically lost a huge amount of weather observations. And this really affected the long-term forecasting. You know, so like the temperatures that are forecasted in day 5 or 6 or 7 from now, that kind of a thing. Didn't have a huge impact on weather observations, or at least the weather that's going on the next day or two, but especially the long-range models, it was. And, you know, the measurements were decreasing by 75% at that point. So we have had to rely a lot on a lot of the other sort of measurements, the radar, the satellite, those weather balloons that are still flying every day, twice a day around the globe. But hopefully now that the aircraft are kind of going back up in the air, we're getting more and more of these observations. And so we'll hopefully see the impact less and less. Next slide. So when it comes to forecasting out there in Kerrville or anywhere, you get all this data from all those different places that I talked about, and they all get pushed into the weather models. And so we use these crazy supercomputers that create a quadrillion calculations per second. Google that after this is done. I forget how many zeros are on quadrillion, but it's a whole bunch. And so they run for hours, and then it produces these output. You've seen this output on the news. You've seen it on Facebook posts where people are showing what the weather looks like in, 7 days from now, et cetera. It's a calculated weather guess is what it is. But its basis is from all those observations that we take at a moment's notice to start that model. Next slide, we'll show a couple of images from weather models. And so this is kind of the output. So when we talk about weather models, when the meteorologist is talking about weather models, this is kind of what we're looking at. And there's many, many weather models. So it isn't as easy as just picking one. You have to look what a lot of them are doing. What are the trends? Right now, we're looking at the weather model trends for the Gulf of Mexico. What are they doing with this system that's kind of disorganized right now near Florida and the Gulf, and it's going to be tracking our general direction. Some weather models are strengthening it into a weak tropical system, like a tropical storm, and others just a blob of thunderstorms coming our way. So you can't necessarily just pick one model. You have to look at all of the models and kind of look at it as an all-encompassing data set. And then use probabilities and math and to figure out what's the most likely scenario to kind of happen. Next slide. And this kind of shows you then kind of what the official forecast output is. It's either some fancy little pictures on our website that says a 30% chance of rain with a high of 93 on, tomorrow or today. It could be hourly output, where a lot of the firefighters use the hourly output for the wind directions, wind speed, and humidities. Or the weather models could be using to, this was a image of Hurricane Florence forecast with that cone of uncertainty that you've always heard about. And, so there's all these different, depending on who you are and what kind of forecast you want, that data that we collect and the weather models are really going to be key as to what that output looks like and how that output is going to actually help you. Next to the last slide now. So this is my little safety spiel for y'all. And it's basically, I want every one of you to have at least 3 ways of getting weather warnings. Around Kerrville there, you can sign up for something called Code Red. You can get the link right through the Kerrville website, and even the Kerr County website has got links to Code Red. It's a mass notification system where you put in your cell phone number and your address, and then you can sign up to get weather alerts and county or city emergency alerts, like a hazmat incident or a shelter-in-place notice or something like that. You can use these good apps that we have on the phone, and there's hundreds of weather apps. Get a good one that you like, that's colorful, that has radar, up-to-date radar, forecast, etc. And then, of course, you can also have a old-school NOAA weather radio that broadcasts weather information and can wake you up in the middle of the night. So there's television, there's radio stations I didn't even talk about. Gosh, there are so many ways of getting weather warnings nowadays. I would say you should be embarrassed if you don't have a way of getting weather warnings, because there's so much great technology nowadays that you need to be able to be in the now and in the know. You don't want to be one of those people when the newspaper comes and says, "Did you know about that tornado coming?" "No, I had no idea. We were under a warning." And somehow they always find that person. So next slide. That kind of wraps up what I wanted to talk about, how, all that data that we get, how it impacts our forecast, how, gosh, out there in Kerrville, you not only have to worry about hailstorms and flash flooding, but basically all the different weather hazards. And then, of course, making sure that we all have ways of getting weather warnings, because the bottom line is I want you guys to be safe, and I want you to be able to know when you get put under one of those weather warnings, especially if you're not even watching television. So looks like I got at least a few minutes here for some questions, and I can take them if you got them.
Paul, this is Clint. I want to ask you one quick question. We had 3 enormous storms in a row in late May. The first one, you all correctly forecast, 80% chance of severe storms. The second one, which did all the damage, you originally said it was going to be a stormy day, and then you wiped it off. No storms. And that's when the second one came. And then the third one you correctly forecast again. How is it with all of the information you have that there can still be a glitch like that?
So I guess I'll play the math. Let's see. I got 2/3 right, so that's 66%. I rounded up to 70, so technically it's a passing grade. Is that correct?
I'll agree with that.
Okay. The hardest thing to still do, we can typically have a understanding of what the atmosphere is doing. The overall chance that we're going to get storms today, the overall chance that we may even get severe storms. But trying to pinpoint where the actual thunderstorms form and move over is still extremely challenging. Gosh, we had a day, and it was in the spring. I'm trying to remember what month it was, where we were already in kind of COVID, you know what I mean? And we were already kind of sheltering in place. And we tried, myself and my wife, we got out of the house. We went to a local hike and bike trail because we wanted to get out of the house and just kind of walk where there was not a lot of people. And it was a day where I'm serious. We had a 0% chance of rain. And sure enough, we had to come home because thunderstorms started to form. And so, yes, even with all this technology, if the atmosphere is not correctly sampled properly, the models suffer. And our nearest weather balloon launch site is actually Del Rio, Texas. We don't launch weather balloons in Austin. We don't launch weather balloons in San Antonio. We never have. Historically, there's not enough money to pay to launch weather balloons everywhere. So we launch in Corpus Christi, Dallas, and Del Rio. And if you look on the map, there's a big, huge hole over the hill country and the Austin-San Antonio corridor. I would love for us to be able to launch weather balloons. It would give us probably a little bit better idea and not have so many misses, but it's still a challenge. And so thunderstorms are still going to be one of those biggest challenges.
Well, Paul, thank you. I think we've just about run out of time. President Tammy, do you think we need to move forward with the meeting?
Is it going to rain today?
If you're lucky, it will. If you're typically an unlucky kind of person, it won't. There's a very small chance. Increasing chances, though, this weekend with that tropical whatever will be coming our way. So I'm hoping that somebody, or at least even myself, will get some nice rain because my yard is burned up right now and we need some bad. So just keep your fingers crossed. Do the dancing like you usually do. Wash your car. Don't put down fertilizer. These are all the tricks of the trade, right, to make it rain. So
exactly right.
Do that.
Does a microburst have an eye?
Say that again.
Does a microburst have an eye? Because at my house, we passed through about 3 minutes of the eye of something.
Yeah, I mean, there's going to be some calmer spots, obviously, of a thunderstorm like that. But no, I mean, typically a microburst, it would be literally when you're driving through it, you'll know it because you've got to pull over because the rain is blowing sideways and it feels like you're in a hurricane. So much small, a very, very small scale. Like I said, typically 1 to 2 miles across at best.
We haven't heard from Tammy. This is George Eichner. Just a quick question. Does the National Weather Service get involved in historical kind of data to go along with the global warming and climate change and things like that? Or are you more current kind of activities?
So a lot of the instrumentation that we have, such as at the airports, that will all be making up all the climate data. So yes, we will, we maintain some of the local sort of equipment at airports. That data then will be documented, quality controlled, and then it makes it into the big climate realm. There's whole other sections of the National Weather Service and NOAA called like the Climate Prediction Center, and they're full of what we call climatologists. I mean, the science of climatology, where they will, they are data crunchers, to the max. So we do some of that locally. We handle some of the climate questions for like the San Antonio media and the Austin media, how many days of 100 it's been this year, that kind of a thing. It's the warmest month on record, that kind of stuff. We can do that. But longer term and the issues of like what the weather is going to be like in 30, 40 years kind of goes higher up into the NOAA climatologists.
Okay, thank you.
You're welcome.
Okay, awesome. I promised everybody they could ask questions because I knew there would be a lot of them, but I hate to cut everybody off. Is there anybody else with a question? We're a little over, but we have Paul, so.
This is Gerald Erie, and I just had one more. Did I understand you to say that a microburst does not have an eye?
Correct. I would not. The only sort of weather feature that we ever describe as having an actual eye would be a hurricane.
Well, at my house, we passed through about somewhere between 1 and 3 minutes of absolute silence in the middle of all the hail and wind.
Right. Most likely what that was when you were crossing through a thunderstorm, that was probably your updraft. Because the air is rising so rapidly, nothing actually falls down through it. So
well, it was hailing and raining like crazy before it, and same thing after, only worse.
Yeah. So there's wind going up and there's wind coming down all around. It's basically what we call convection, right? Up and down motion. And so whenever you get those calmer spots, those are typically the updrafts or the air going upward in a thunderstorm.
Totally silent.
Yep. Yeah, and for all those, and I know you guys are running long. If there's other questions, write them in, and Clint can send them to me, or somebody there can send them to me. I'll answer them. I'm teleworking, so I've got some time.
Great. Well, thank you so very much. We really appreciate it.
Thank you.
It was really fascinating.
Great.
You're welcome. I'm going to drop off, but have a good evening or afternoon, everybody.
Thank you again. I don't know that Stephanie Miller is online with us.
She's here.
Yay. Okay, there you are.
Yeah.
Do we have
Yeah,
families of Rotary?
Yes, I have 3. I wasn't on last week, but I didn't know if anybody knew Mark Armstrong had back surgery and then had to go back in because he got an infection. So keep him in your prayers. Carolyn Northcutt's husband is in San Antonio in the hospital, and he's got COVID. So prayers for him. And then Betty Vernon's brother passed away this week. And I believe the funeral was this morning. So that's all I have.
Well, there's lots of Rotarian people to pray for there. Thank you so much for sharing that with us.
Yes.
We're going to hold off on our club runner moment that we promised last week, but I think we'll do it at the beginning of the meeting, Christy, and that way you can actually get it in, because I think that's going to be really important. So we'll do that next week. I have a note here about Ed Hamilton's Bur Oak contest, and I'm not really sure what that's about. I know that he asked us to send pictures of his trees, and he's going to pick the winner, and the winner will get a Paul Harris Fellow Award. So, Christy, do we have an email address or any further instructions for those people that would like to compete for that Paul Harris Fellowship?
They can, if you don't know Ed Hamilton's email, you can send it to me and I will forward those pictures on to him. But he wants to see how many people still have a little tree coming up from those bur oak acorns, and he wants to give away a Paul Harris. So he said it's time to take pictures of your trees and send them. Again, if you don't know his address, if you can't get onto Club Runner and get that, that's fine. Just send it to kerrvillerotary@gmail.com and we will get those pictures.
Great, thank you. And then also, Christy was instrumental in so many things in our club, but also most recently with helping us create a community Rotaract club made up of young professionals that are very energetic. And they have decided to do their first service project, which will be to clean up the river as part of the UGRA river cleanup. They're going to do this. UGRA had to cancel the organized one that they do annually. However, they're reimagining it, and that's the words they use, reimagining, and they're asking individuals and organizations to still go do it and report back to UGRA, and our Rotaract Club jumped on the chance to do that. Do you have anything else more to say about that particular project, Christy?
No, it's this Saturday from 8:30 to 10:30 for 2 hours. And the area that they've decided to clean up is along the river and along Riverside Drive, which I think most of you know, that's kind of near the VA hospital. It's at the intersection of 534 and Riverside. And so there'll be a land crew. And for those of you who have maybe a kayak or a canoe, bring it on down. We'll get you on the water and you can pick up all the stuff that's down there. It's amazing how much stuff floats down once we've had a storm. So 8:30 to 10:30, we'll take pictures of all of us in wear your bright yellow Rotary at Work t-shirt and come on down for 2 hours on Saturday.
Okay, great. And I don't think we have any other announcements. Our next meeting will be, we'll hear from Dan Schultze and his wife of Turtle Creek Olives and Vines, and they have a really unique and interesting story, and I can't wait to share it with each of you. I would ask you now to join me on the 4-way test. Of the things that we think, say, or do,
is it the truth? Is it fair to all concerned? Will it build goodwill and better friendships? Will it be beneficial to all concerned?
Thank you all. I hope you all have a great week, and I can't wait to see you next week.
See you guys.
Bye.
Bye-bye. Bye-bye.